something a little more close to home, and I just get to that. So I work for Unilever, as you said, and so most of you may not know Unilever, you know all the brands that we have, right? So there's a whole lot of brands that everybody is well aware of. And I think I put it up not just to say that these are the brands you all know, but to say that these are products that we use every day. Right? So these are really everyday products that we hardly stop to think of. But the one thing that's common amongst all of this is the fact that we use a lot of material. Right? So if you think about this, all of these are materials that are derived either from agri, or from petro, or from mining, and that go into this product. Yeah? And that's what we use every day and discard down the drain most of the time. So an extremely material intensive industry is what we represent at some. Right? And if you think, and actually if you look at our GHG footprint, almost 95% that comes from the raw materials that we use. Very little is actually goes into the processing and the so that's the sort of reality of what we do. And in that scenario, what I wanted to do is really talk about something that, like Professor Doshi said, we all use every day, a bar of soap. Right? And use that as an example to really talk about sustainability and why it's important, how it has to progress as we sort of. So what I've done is I start with a little bit of history and sort of talk with the technology, innovation, research, and the policy aspects that have shaped how we came this way. Yeah. So just to sort of get everyone on the same page, soap as said the mainstay of mass hygiene and extremely critical. I think COVID made it very, very sort of critical that washing your hands with soap became sort of the norm. And if you look at what a soap is, a soap bar, if I'm going to talk specifically on a bar, so a soap bar is really about 80% constitutes what is known as a soap molecule, which is basically a sodium or potassium salt of package. Right? So it's a molecule that has a head that likes water and a tail that doesn't, which is why it likes it. Right? And the process of saponification simply is oil reacting with alkali to give you soap plus glycerin. Yeah, so simple process. Yeah, and so what is key is a soap bar actually hence has anywhere from 70 to 80% palm oil. So it's not oil, but it's in the form of saponified oil, but about a bar really constitutes about 70 to 80% oil. So that's the what we have. Yeah. And if you look at soap, right, I mean they have been known for many, many years. So this is the first reference to soap is actually 2800 BC, right? So we have known soap for 2500 years. In fact, I like to say it's not just about it. The first probably chemical reaction ever recorded because the tablets actually said facts for boils with ashes. Yeah? And so the story goes where they would have animal sacrifices and temples and ashes, and the hot ash would actually react with the fat, and that's how the soap got formed. And they realized that they could clean a lot better in that material. And in India, if you look at, I think one of the earliest soaps that came was actually from the US in 1988 is when sunlight came to the ports of Calcutta. Right, in 95, and India itself started making it. So Tata was the first company that actually bought OKR units in Kerala and started opening soap in 1980. In fact, Google always says that it's Tata, but actually if you look at Mexico Sandal, that also started in. So factory actually started in 1916 and the soap was. Yeah, so they are almost equal in terms. Very interesting stories about all of them, but I will not go there right now. So the sustainability journey, right? So I'm going to talk about the raw materials that go into making a bar of soap and why is that so important. If you look at soap, when it first started, right? The key material, it was not oil that people talked about at that point, it was the alkali. Yeah, and alkali was made from basically from burning down wood or seaweed. So you had to take ash from wood, and depending from where the ash came from, it would either be sort of potassium or sodium heavy, and then that gives you sodium or potassium carbonate, which will dissolve in water to give you alkali, right? So sodium hydroxide. And alkali became an extremely prized possession at that point. Not only because soap needed it, alkali was also important for the textile industry and glass industry. And I think all of Europe practically went crazy cutting down trees because they wanted that ash to generate alkali. That was the only way of generating alkali at that point, right? And to the extent that there were laws passed against cutting down forests. But in 1783, actually, King Louis XVI, along with the French Academy of Sciences, actually offered a reward for anyone who could produce alkali from sea salt. So that is the cheapest raw material available. And of course, in response to that, and the detectors, the glass of scientists first came up with a method to make alkali from So, or to make soda ash from salt in 1791. And if you look at the process, it's an interesting process actually. But what I want to focus on is all the byproducts of that process. Right? So though it now prevented the cutting down of forests, what you realize is that you are letting down a lot of obnoxious materials into the environment, right? HCl, CO2, calcium sulfide. I mean, and this is just a visual of the factory, but so you landed from one problem into another. In fact, this was the process which was actually responsible for the first Pollution Control Act, the Alkali Act as it was called in 1863. So the first sort of Pollution Control Act came because of this. And then, of course, eventually we all know Solvay came up with a much more cleaner process, a circular process. We are not talking about that could be used to create that. And Solvay still remains as one of the top producers of soda ash after all these years. Right? Just a side, I mean, Solvay did get, make a lot of money, invested a lot of it back into science. Yeah? So I think he started the Institute of Physics and Chemistry, and we all know the Solvay conferences that have sort of hosted a lot of Nobel laureates over the years. Yeah? So that's the history of soap. I mean, talking of policies, right? So these were the talked about the Pollution Act. The other was soap being taxed, right? So soap was taxed as a luxury item for the longest time because people didn't realize, they thought it was a luxury item, right? And there was another reason for it. The other reason was that soap was always made from tallow, yeah, and tallow was also used to make candles. So the thinking was that if the tallow is diverted to making soap, then they won't be enough to make the candles. And so the law was passed to make sure that people have enough light, right? So that's how it happened. But later on, of course, the electric bulb came much later. But John Stowe actually then showed the whole germ theory from the study that he did in London, and then talked of hand washing as the way to counter bacteria and germs. Right? So that's when people realized that it was not a luxury item but a hygiene or something that would prevent diseases. That the next the soap tax was abolished, and that was only in 1853. So after that, actually, when I think soap really took off, became an increasingly important factor in public health. We like showing this figure because after that is when life expectancy went up quite drastically, right? I mean, there were various reasons. I guess the soda ash also liberated, you could make glass better and textile better. But yeah, that was one of them. So that's the sort of sustainability journey of soap. And the question really is, what are we still doing, right? It's been 4,000 years since it's known, 100 years, 100 plus years since it's been in the country. And today, I think the question is all the other raw materials that soap is made of, right? And like I said, soap is 70 to 80% oil in there, right? But the important thing is that not all the soap molecules, that 80% soap molecules in a bar of soap are identical, right? Because when you use oil is a triglyceride with different chain lengths, right? And I've just put down a figure showing different chain lengths of various oils that are available. And so why is that important? That's important because only the short chain oils will form soaps that are soluble, right? So only the C10 soaps are actually soluble soaps. The long chain soaps are insoluble soaps. They're not going to be soluble. So sodium stearate, C16 are not soluble at all. They will stay as insoluble. Right? So what is the function? When you think of a bar of soap actually, we think of it almost like a brick and mortar structure. Right? Where the mortar is constituted by the soluble soaps, the short chain soaps are the unsaturated soaps, and the bricks are made by the saturated long chain soaps. Right? And so if you look in a bar, typically about 60 to 70% are the bricks, the remaining 30 to 40% are the soluble. So what is the mortar is what is actually responsible for the lacquering in the bar of soap. Right? And what the 60% bricks do is only provide a structure, only give you a solid bar, basically. So that's the sort of irony of that bar, because all that 80% oil that go in there, only about 20 to 25% of it is really required for the function that it's supposed to, that you need it for. The rest of it is only there to give you a structure. Right? And I think that's the sort of problem that we are trying to solve. So, of course, I mean, today most of the soap is made from palm oil, and there's a lot of deforestation people, and we've heard of the sort of things associated with palm. Equally, what happens is when you use the bar, all that solid soap gets separated and goes down the drain. Right? So you are actually creating a load on the environment as well, because it's not useful, but it's still going into the water. It's almost a double value. And just to sort of put it in context, Unilever itself makes 1 million tons of soap, right, every year. I mean, the world, I think the total tonnage is about 3 million. But that's the inefficiency that we have been living with for a good 100+ years with the central part of it. Yeah, and so the question is, how do you really do this? So one part of it is, of course, you say, okay, we use better oils, alternate oils that are more sustainable, biotech, we would get animal oils, which is, of course, will happen, and that's things that are happening. But what we can do as R&D in the soap industry is really look at how to structure something much more efficiently, right? I mean, if you look at, like this example of a fruit, because a fruit is 80% water that is presented to you by nature as a solid. So why do we need 8% bricks or 60% bricks to make a bar? So that's the sort of motivation we need. And that's the journey we are on. So what we are trying to do is, how do we hence reduce the amount of solid bricks or the non-functional part of the oil that's used in the bar. And really various routes that we are adopting as we go along. We say how do you sort of have the morphology of the bricks to be structured better. How do you replace the soap or the oil bricks with something that is more sustainable? And finally, of course, how do you get more water in it? Right? I mean, a lot of people tell you, you're putting water, so you're diluting the product. No, we are not. We're just making it more sustainable because it's the right thing to do in some sense. Right? And so the ambition really, this is the journey we are on. I think we want to cut down the oil and soap by over 50%. That's huge implications. Right? And what we want to do is really take that insoluble soap and replace it with more sustainable. Leave the soluble soap the same. So you're not going to change any of the associated benefits or properties of the bar. And that's what I was showing down. That's work that we actually published recently, where we have shown that you can generate the same data, you can get the same amount of bacterial kill, which is one of the key functions of the bar of soap. Equally, if you reduce the soap, you can make a bar more mild because you can have space in it to put in other ingredients that might be more useful for your skin. Right? So you can actually engineer a bar a lot smarter than what we have done over the years. And that's sort of the so that's where we are. I just put this down as numbers because I thought this was a good meeting to sort of show this in other things. So that's the sort of excellence. India makes about 800 to 1,000 kilotons of soap every year, right? And most of it is imported palm oil. And like I said, if we can cut down that 40-50%, it has a huge impact on the imports that we make from palm. And what I've put at the bottom is actually the GHG number, so we can get up to 25% to 40% impact in GHG saving, as well as a lower burden on the environment, because if you have lower soap containing bars, then your wastewater treatment, the BOD, CODs also go down by about 25%. So that's where we are. By the way, so we have bars, we have taken them in the market. I think where I want to put down, again, the role of policy and regulation is because in India we still have, this classification of bars where we call them as grade 1, grade 2, grade 3, based on the TFM. TFM means the total fatty matter, so the amount of fat oil that you're using in the bar. And so what this does is, the implication is that 76% is a grade 1 or 70 is a grade. And below 60, you can't even call it a toilet soap, actually. You call it something else. Right? We call it a bathing bar. But that's the, so what we are conveying is that a high TFM is a good soap bar. While all it means is that it has material that's really not, it's an inefficient bar, or that's how I would put it. So really the thinking, and this is what we're pushing, really is saying that the regulation should be performance-based. By the way, most of Europe has done away with, or most of the West has done away with this gradation system. It's only based on performance, right? Not on ingredients, but on sort of the lathering, the cleaning, all of that. And further research scope to sort of bring this as, eco marks or what have you on products that are genuinely sustainable, right? So how do we identify what is sustainable? And something like this, I think, has that potential. So that's really the story of soap, and so thank you for listening. And that's our ambition to go and learn so far.